example again in the future. Okay, so now here's another problem that we've already touched on, but we haven't seen how to solve it, right? You could think of it as the zip code problem, right? The zip code might look very good as a predictor for the class, even though it's not. In fact, let's suppose that you have a data set with just 1,000 examples, right? And as it happens, everybody there comes from a different zip code, right? That could happen, right? I claim that you would always pick the zip code as your best attribute. In the worst case, it would tie with some others, right? But why would it be impossible to beat? Right? Every example has a different zip code. So what's the information gain of the zip code going to be? Or like, what's the error rate after I split on the zip code?
None.
Exactly, the error rate's going to be 0, right? Because the zip code picks out one specific example that has one class. So with the zip code, I can always predict correctly. Does that mean that the zip code is a good thing to split on? No. In fact, one of the beginner traps is something like this. You get your data set, every example has an ID. Like your social security number, or just like the number, of this thing from the web log or whatever. Right? And you forget to take that out. And then of course, you can predict the class, is this person going to leave my website or not? This is what the project is about, right? Perfectly, using that attribute. Did you get some generalization out of that? You got 0 generalization out of it. Okay? So, nevertheless, we don't want to throw away multi-valued attributes because they could be very useful. Like, for example, the zip code for marketing is indeed one of the most, predictive attributes you can get. Okay? So what might we do? Well, there's actually lots of things that we could do, but let me just give you one simple, easy-to-code heuristic that actually works quite well. And this is the following. If you think about it, the problem with an attribute with a lot of values is that there's a lot of information in just splitting on that attribute even before you think about the class. Right? You have a set with a lot of values, right? So there's a lot of information in telling you which member of this set I am. Right? If I tell you which zip code I live in, that tells you a lot. Even before you find out how much money I make or whether I like to buy yachts or not. Okay? So what we want to do is we want to compensate for that. We're really only interested in the extra information about the class that I get from splitting on that attribute, beyond the information that I unavoidably get just from the entropy of the attribute by itself. Okay? So what I can do is I can use what's called the gain ratio. The gain ratio is just the ratio between the information gain, as we saw before, right? How much information does this attribute have about the class, and the split information. The split information is just the entropy of the attribute itself, right? I have a zip code, some of them have more people, some of them have fewer. What is the entropy of my zip code membership, if zip code is the variable, right? And then I do the ratio of the two. Which means that if you're in a zip, if you have an attribute with a lot of values that are widely distributed, then you have a high burden to bear to prove to me that your information gain is actually coming from really predicting the class as just happening to have a lot of values. Okay. Quick question: why use the entropy and not something simple like just the number of values? Why don't I just divide by the number of values? Right, that would be easier. Right, and if there's 10,000 zip codes, I divide by 10,000. Why use the split information instead of that? Let me give you sort of like a hint, right? Let's suppose that we actually were in a situation where each zip code had exactly the same number of people, right? Would it make any difference whether we were splitting, on the number or on the actual, or on the entropy? Not really. But now let's look at the opposite case. Let's suppose that we have a lot of zip codes, like, maybe a more recent example would be country, right? But some of them have many, many more people than others, okay? Would you rather split on that, so two attributes with the same number of values, right? Would you rather split on the one where the values are very evenly spread or the one where they're very concentrated? Concentrated, why?
So that gives us a better filtering mechanism, better gain.
Yeah, because think about it this way, think about it in terms of country, right? Like over 10% of the people in this world are in China, over 10% of them are in India. And then there's all these minuscule countries that are probably not even in your data set. So to a first order approximation, without offending anybody, you could model the world as just India and China, right? And that would be an attribute with two values, right? So here's the key: is that an attribute with very few values is almost like an attribute with a lot of values but very concentrated distribution is almost like an attribute with fewer values. Okay? Now in practice, what you might want to do is aggregate, for example, all little countries into larger regions, like say Europe and North America and whatnot, right? But so that's an intermediate case where you're actually getting a smaller number of values, but probably still the same predictiveness. Okay? This is why you want to use entropy, right? One good way to think of entropy is that at one extreme, entropy is like just the log of the number of values that you could have. But at the other extreme, right, suppose that you have, only 2 values can occur. Then this is the same thing as a binary split, right? If you have a data set with, 100,000 values where only 2 of them occur, right? This is effectively the same as, only having 2 values. If you have a data set with 2 values that each occur 1 billion times, and then 1,000 times that each one of them occur only once, right? Well, this is a data set with really 1,002 values, but effectively it's almost just like splitting all those 2 values. Okay? Questions? All right.